Great, thank you. So today I will be telling you about Occator Crater on Ceres, which you can see here in the background. Next slide, please. Occator is the youngest large crater that is on Ceres. It's about 92 kilometers in diameter, and it contains the well-known bright spots, which are called faculae. You can see the two main regions of faculae in A and B images on the right. A shows the center of the crater, where Ceres Facula is located mostly in the central pit, and then Facula Facula is located on a ledge above the pit, labeled B. Then in the eastern crater floor, we have the Venalia Faculae, and you can see that they are associated with large-scale pit chains and fractures. And these faculae are thought to form when brines percolate up from the subsurface, and then as they are exposed on the surface of Ceres, they lose the liquid water component, and the bright salty residues are left on the surface to form the faculae. The aim of our mapping study was to use the highest resolution dawn data to create the most detailed geologic map of Occator's interior, including these faculae. And this data was up to about 3 meters per pixel, and it was taken during the latter stages of the dawn mission. Next slide, please. Here is the geologic map that we created, and I'll briefly take you through the different geologic units. The faculae are shown as the different shades of blue that you can see in the center of the crater in the eastern crater floor. They are mapped based on their texture, which ranges from continuous through to discontinuous, with kind of a moderate unit in between. The central Ceres faculae are mostly continuous, and the Venalia faculae are more discontinuous. Surrounding the central pit in the purple unit, we have high-standing massif material. Throughout much of the interior of the crater floor, we have the green units, which are lobate materials. These are thought to have been in place relatively shortly after the crater formed as a slurry of impact-melted water ice mixed with salts and other solid rocky particles and kind of sloshed around the crater floor before it solidified. We divide them up also based on texture, which ranges from smooth down in the south to hummocky up in the northeast, the kind of darker green unit. The rest of the crater floor is crater floor material, which is the salmon color unit, and then terraces, which are orange. And these are also coated to a greater or lesser extent by the lobate material. And then on the steep crater walls, we have the talus material in pink and the spurs in brown. By doing this geological mapping and the associated geomorphic analysis, we find that the faculae are emplaced via a process that we called brine effusion. This is very similar to how hydrothermal deposits are emplaced in impact craters. We think that they are mostly emplaced ballistically, but perhaps there were some short-lived flows. And rather than there being one centralized source region for these brines, we think that there were numerous localized sources throughout the regions in which they occur. Pathways to the surface for these brines that went on to form the faculae were enhanced via impact-induced fracturing, and while there were plenty of brines around to form the faculae that we see today, the system was probably rather brine limited. This is because we often see dark patches within the faculae that are not simply topographic highs. It seems like there just wasn't enough brines to cover those patches. And also in particular, Venalia faculae is pretty thin. That whole area is only about 2 to 3 meters thick on average. Next slide, please. In combination with the modeling and geophysical studies that you can see listed in bullet 3, we were able to get a pretty good idea of what the subsurface structure is underneath Occator that you can see in this cross-section. This is a real cross-section. The colors correspond to the units that I showed you in the previous slide in our geologic map, and of course there's a lot of vertical exaggeration. We think that the central Ceres facula is mostly sourced by an impact-induced melt chamber that partially merged with the deep brine reservoir that's located throughout much of Ceres subsurface at the crust-mantle boundary. This deep brine reservoir enabled Ceres facula to be formed maybe 20 million years or so after the crater itself formed, and it wouldn't have been able to be such a long time period between the formation of the crater and the formation of the faculae if they were only sourced in the impact-induced melt chamber. So the deep brine reservoir, we think, basically recharged that impact-induced melt chamber in the center of the crater. Venalia faculae in the eastern crater floor are probably only sourced from the deep brine reservoir, and this means they would have taken a pretty long path to the surface through some of the fractures that you can see represented as those black lines. And that's consistent with Venalia faculae being much less voluminous, much thinner, and much more ballistic emplacement than Ceres facula. We think the ballistic emplacement is because the brines coming up from the deep brine reservoir would have been under higher pressure than the ones coming from the impact-induced melt chamber, and so they would erupt kind of more ferociously in the ballistic emplacement as they were emplaced onto the surface. Next slide, please. So our near-term future plans are to publish the map that I showed you in Nature Communications, which is coming out in a special issue about the final dawn observations on August 10th. But as you can see from the figure on this slide, our map is only one of many maps that have been made of Occator Crater. Ours is panel E, and you can see there's a lot of others. So myself and Deborah and Dave, who I think are online, are currently proposing a PDAR study to produce a new consensus view geologic map of the interior and ejecta of Occator in the format of a USGS sim. This would be the definitive self-consistent map for the community to use in future science investigations and also in situ exploration. The in situ exploration was shown in the recent Ceres PMCS study. It was shown that Occator and its faculae are a prime candidate for future exploration, so our geologic map would be very helpful for that as well. And it would be the only published map of the crater that would be a consensus view based on the highest resolution dawn data. And if you want to learn more about small bodies, I have a GSA session coming up with Deborah and Kynan. Please submit to that. Thank you.